Hello my friends, welcome to this new practical tutorial where we're going to get this time the inputs and outputs separately into separate variables. Alright, so let's create a new code cell, and now do you remember what we have to do? We need to create an array of the independent variables, all these independent variables here, and a vector, an array of one dimension for the dependent variable, which will contain the whole class variable. Alright, so let's do this. It's gonna be almost the same as before, but there is one important change that we must do, and if you try to do it before me, maybe you thought of that. So let's see, I'm gonna reveal it soon, but first let's create our two variables. So for the array of independent variables, we're gonna call it x, just like before, and for the vector of dependent variable, we're gonna call it y. Okay, so let's start with x. Remember, we are going to take our dataset first, and from our dataset, so we add a dot here, we're going to call the iloc function, in which you have to enter the indexes of the rows and the columns you want to extract from your dataset. Alright, so first let's start with the rows, the easy step. Of course, we want to take all the rows, right, in our array of independent variables, and so just like before, we're going to enter this colon here, which means the whole range, because we don't specify any lower or upper bound, it means the whole range of rows. Then we add a comma to separate the rows from the columns, and now we select the columns we want to extract into our array of independent variables. And that's where the change comes into play. Among all the features here, do you see any feature that is not really relevant to predict our dependent variable? Well, of course, I'm talking about the sample code. The sample code is just an idea and has absolutely no impact on the class dependent variable, right? Of course, there is absolutely no correlation between some sample code numbers and whether or not some patients have a malignant tumor. And so, it is much better to exclude this column here because, this could cause some bias when we are training the model. When the model learns all the correlations between the features here and the dependent variable, it might be biased by this variable that has absolutely no correlation with the dependent variable. Alright, so we must exclude it, and therefore in our range of columns that we want to select here, instead of starting from the first column by not specifying any lower bound on the left side of this column, well, we're going to specify the first index that we want to include in our range, and that's of course the index of the clump thickness column. And of course, since indexes in Python start at 0, this has the index 0 and this has the index 1. And therefore, in our range here, we must start from the index 1. And that's the only change we had to do compared to before. The rest is the same. We're going to exclude the last column, and therefore we're going to add here -1, because I remind that this -1 index means the index of the last column. But since a range in Python excludes the upper bound, well, this last column of index 1 will be excluded. However, the lower bound of a range in Python is included, and therefore the second column here of index 1, clump thickness, will be included. Alright, and that's it. That's all you needed to do to adapt to our new dataset. And then it's the same. We're just going to add dot values here to make sure x is an array, right? Because this is the format expected by the train testsplit function, which will take as input indeed x and y, and will return the training set and test set. Alright, so now let's do the same for y, and so we're going to do this efficiently. We're going to copy this, and then we're going to paste here, and for y it's just exactly the same as before. Y is our dependent variable, and our dependent variable here is the last column, so we simply need to take the index of the last column, which is of course -1. So no range here, and we are ready to get our dependent variable vector y. So let's play or run the cell. Here we go, successfully run. And now let's just add a new code cell to, visualize a bit what we're coding. And so let's display x first. X. So here is x, including indeed the features from only the clump thickness, right? 553 and 553. All right, so we start from the clump thickness column up to the mitosis column, which is our last feature. And then, with all these features here, well, we are going to predict the dependent variable vector y, which we're going to display now, and which contains all the classes which tell whether or not patients have a malignant tumor. So 2 means benign and 4 means malignant. By the way, for some reason we can see all the classes in our dataset, for all the patients. And what's interesting to note here is that we have a very well balanced class distribution. You know that when working on your datasets and doing data preprocessing, you must check that there is no class imbalance, which means an imbalanced distribution of your classes. But here we seem to have a pretty well balanced distribution of 2s and 4s, which will definitely help the training of our logistic regression model. Alright, so here we go, we are ready for the next step. I'm looking forward to implementing it with you in the next tutorial, and until then, enjoy machine learning.